All right, today we're looking at particle motion, and this is going to bring a lot of physics into this concept, of derivatives and integrals. One thing that I will start by saying is the relationship between position, velocity, and acceleration. So position, usually written as x of t. If we take the derivative of it, so this is the derivative, we get velocity, usually written as v of t. And if we take the derivative of that should be a v there, we get acceleration, which is a of t. Now, going the opposite direction, we're doing the integral. So the integral of acceleration is velocity, integral of velocity is position. So they're inverses of each other in the sense that taking the derivative goes down one way, taking the integral goes another way. So with that in mind, we're given a velocity versus time graph in feet per second, and we're asked some questions about it. So first one, at t equals 0, is the particle moving left or right? Well, at 0, the velocity is positive 2, which means a positive 2 means the velocity is 2 in the positive direction. So it is moving to the right because v of 0 is positive. Okay? When is the particle at rest? This is when is the velocity 0. And it looks like it might be at rest here, but remember, the velocity is the graph we're looking at. So that's a velocity of 5. It's at rest here and here because of the two times when it's 0. T equals 9 seconds and 17 seconds. When does the particle change direction? So when is the particle moving from right to left or left to right? Now, a lot of people will look at this and immediately say, oh, it's going to be right here, right here, right here, and, well, maybe right there. All right, because the line's changing the direction. But remember, this is the velocity. This right here is a positive velocity that's getting closer to 0. So that's someone slowing down. And then it starts speeding up again in the opposite direction down here. So this is a negative velocity getting much more negative, becoming more negative. So it's actually changing direction here. T equals 9 seconds. When is the speed of the particle the greatest? This is the magnitude of the velocity. So it's saying when is the magnitude, when is the numeric value of the velocity the greatest? Well, the numeric value is the greatest right here when t is equal to 15. All right, this one gets close. It gets to a velocity of 5, but this is a velocity of -6, which means it's moving the fastest. It's moving 6 feet per second to the left, which is the fastest it moves. All right, let's keep building off this. What is the acceleration of the particle at t equals 1? We said acceleration is equal to the derivative of velocity. Okay, so if we're looking for the acceleration at t equals 1, that means we're looking for the derivative of velocity at t equals 1. So that's this point right here. We need the derivative there. And remember, derivative is just the slope. So we're saying the slope here. That's a rise of 1, 2, 3, run of 2. So a of 1 is equal to 3 over 2. And we need units. This says feet per second is our velocity. If we're doing feet per second, and then again, it's going to be feet per second squared. What is the acceleration? When is the acceleration 0? So in other words, when is a of t, which is equal to v prime of t, the derivative, equal to 0? When is the slope 0? Well, right here. That's the place where the slope is 0. So that's from t equals 2 to t equals 6. We'll write it this way. When t is between 2 seconds and 6 seconds. Now, the last is the total distance traveled from for the particle. This kind of brings in what we talked about in yesterday's lesson. We said to go from velocity to position, it's going to be the integral of velocity. Now, that gives you the position. So that gives you how far away are you from your starting point. If you want the total distance traveled, that's going to be the total area like we talked about yesterday. So the integral absolute value v of t dt. That's what we want for total distance. Okay, so now with this in mind, we're going to have to break it up like we did yesterday. We want to break it up by all of our zeros, and we're going from 2 to 14. So we break it up by all of our zeros and just make them positive areas. So here we have 1, 2, 3, 4 by 5. So that's going to be an area of 20. Then here, we have 1, 2, 3 times 5 is 15, so 15 over 2. Here we have 1, 2, 3, 4, 5 by, oh man, let's see, where is this going to be? We'll say that's at 5, so 5 by 5, which is 25 over 2. And instead of making this negative, because we're looking for the total distance or total area like we talked about yesterday, there's going to be positive. So 25 plus 15 is 40 over 2 is 20 plus 20 is 40. So total distance traveled was 40 feet. Now, that is not in any idea of where the position is, because technically it traveled this much in the positive direction, this much in the negative direction, so its position is not 40 feet from where it started. It just total distance traveled is going to be 40 feet. All right, now we want the position of the particle at t equals 14. Well, that's going to be a little bit different. That's going to be, okay, where exactly are we located? So position is going to be the integral from 0 to t of velocity, or position at 14. Let's do position at 14. 0 to 14 of the velocity. I really need to write this better. Of the velocity. Now, there's another part that's not here. It's not just this. It's plus whatever the position was at 0. Now, in this problem, we're not given an initial position. It doesn't tell us where it was initially. So we're just going to do this area from 0 to 14. But in future problems, it'll give you an initial position. We saw one like this on the test. We didn't actually say it was particle motion because it wasn't really a particle moving, but we were given an initial value, and you had to add that to it. So we're looking for all these areas. We already said this area was 20. This is 15 over 2. This is going to be negative 25 over 2. And then we need this little bit back over here as well. So this is 2 by 2, so that's 4. This is 2 by 1, 2, 3, so 6 over 2, which is 3. And we're going to add all these up. So we get a negative 10 over 2, so negative 5, plus 20 is going to be a positive 15, plus 7 is 22. So it's 22 feet. And now, because we're talking about position, we need to talk about the direction. We would say it's 22 feet to the right of its initial position. Okay? It's 22 feet to the right of its initial position. Or you could say it's just 22 feet. A positive 22 feet means the same thing. When does the particle reach the maximum position? So when is position a maximum? This is going to be really interesting. All right? First off, we need to think about what we're looking for. We're looking for where x of t has a max. Well, that's an absolute max, so that means we're looking for both critical numbers and endpoints. And we're going to set up our table of values. So here's our t. Our endpoints are going to be 0 and 22. And the critical numbers are going to be where the derivative is equal to 0. And this is the great part. We said the derivative of position is velocity, and we have our velocity graph right up here. So it's equal to 0 here and here. So at 9 and 17. And so now we actually figure out what that position is. We find x of t, which is going to equal the integral from 0 to t of v. And really our variables we're using start to be really weird. We'll use a different variable. We'll use d sub I, di, something like that. Okay, because this variable and this variable have to match. All right, so the first is the integral from 0 to 0. That's just going to be 0. Integral from 0 to 9 is just going to be this positive part right here. So that's 27 plus 7.5, so 34.5, 34.5. Then to 17 is going to be adding this little bit right here. So let's actually change that. Let's just find the whole area of this triangle. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 6. So negative 24. I'm pretty sure. And that gives us negative 24 plus that 34.5 should give us a 10.5 there. And then we're going to check at the end point, which means we have to add this little triangle here at the end. So 1, 2, 3, 4, 5, and that's another negative 5, so negative 25 over 5, or negative 12.5, or sorry, over 2. Negative 12.5, so minus another 12.5, should give us negative 2. So the maximum is 34.5 feet at 9 seconds. And then what is the particle's minimum position and when does it occur? Minimum is negative 2 feet at t equals 22 seconds. Okay, so that's the general idea behind particle motion, just different relationships between velocity, position, and acceleration. You have a worksheet to work on. Let me know if you have any questions. You have a great day.